In this video, we will solve a past paper of GIKI. Question 1 says that a rock is dropped off a cliff and strikes the ground with an impact velocity of 30 meters per second. How high was the cliff? From the question, we know that the final velocity is equal to 30 meters per second and the gravity is equal to 9.8 meter per second and initial velocity is equal to 0 meter per second. Now we will use Newton's second equation of motion, which is Vf square is equal to Vi square plus 2gh. Now we will put values and we will solve for height, which is equal to 900 divided by 19.6, which is approximately equal to 45 meters. Therefore, D is the correct answer. Question 2 says that a ball is released from the top of a tower of height h meter. It takes t seconds to reach the ground. What is the position of the ball in t by 3 seconds? Now here we know that the acceleration of the ball will be the gravity and the initial velocity of the ball will be 0. The equation of motion we will use is S is equal to Vit plus 1 over 2 gt square. Here this part becomes 0 as initial velocity is 0. Therefore we can say that S is equal to 1 over 2 gt square. And now as we have to calculate the distance when time was t over 3, therefore we can write it as t over 3 whole square. This was the height before and this was the height we have to measure. We can write it as 1 over 2 gt square over 9. Now if we compare both of these equations, we will get S is equal to S over 9. So we can write it as h minus h over 9, which is equal to 8h over 9. Therefore, option C is the correct answer. Question 3 says that if Earth shrinks to half the present radius, the duration of the day and night will be. If this is the Earth now and this is the Earth after shrinking, we know that the mass remains same for both of these, but the radius is divided by 2. If this has the moment of inertia I, we have to calculate the moment of inertia for this Earth. Therefore, we can say that I is directly proportional to r square. So from this, we can say that if radius is divided by 2, then the inertia will be divided by 4. Therefore, this Earth has moment of inertia which is I by 4. So we know that I1 is equal to I2, which is equal to omega 1 over omega 2. We know that omega is inversely proportional to the time period, so we can write it as I1 over I2 is equal to T2 over T1. Now we know that this I1 is inertia, while I2 is I by 4. Therefore, we can write it as I over I by 4 is equal to T2 over T1. Now by solving it for T2, we will get T2 is equal to T1 over 4. We know that the time period of day and night on Earth is 24 hours. So the time period on the Earth, if it shrinks to half the present radius, it will be 24 divided by 4, which is equal to 6 hours. Therefore, option C is the correct answer. Question 4 says that light roofs are blown off during windstorms. It is because here I have a house. Now this is the roof of the house. Normally the pressure outside the house and inside the house is equal. But when there is a windstorm outside the house, the wind is like this and the roof is blown off. This is due to the pressure difference. Therefore, option C is the correct answer and we can say that the light roofs are blown off during windstorms. It is because of the difference in the pressure. Question 5 says that the maximum velocity of a simple harmonic motion is a naught. The period of oscillation is. We know that in a simple harmonic motion, the equation that relates x and t is x is equal to a sine omega t. Here a is the amplitude and omega is the angular frequency. So we know that the velocity is the derivative of displacement. So we can write it as v is equal to a omega cos omega t. From this we can say that the velocity will be maximum when cos omega t will be equal to 1. So we can write it as v max is equal to a omega as cos omega t is equal to 1. And according to the question, the maximum velocity is equal to a naught. So we can write it as a naught is equal to a omega. From this we can solve it for omega, which is a naught divided by a. According to our options, we have to find the answer in terms of a naught and x naught. So here x naught is the amplitude. So we can write it as a naught divided by x naught. Talking about the time period can be calculated by this formula, which is 2 pi over omega. By putting the values of omega, we will get 2 pi divided by a naught over x naught. By simplifying it, we get 2 pi x naught divided by a naught, which is option A. Therefore, option A is the correct answer. Question number 6 says that in wave motion, the least distance between 2 points which are out of phase is, we know that the least distance will be the half of their wavelength. So if their wavelength is lambda, their least distance will be lambda by 2, which is option B. Question 7 says that a particle performing simple harmonic motion when its displacement is 3 cm, its acceleration is 12 cm per second square, it is vibrating with period. Now to solve this, we know that the displacement is 3 cm and we also know that the acceleration is 12 cm per second square. So we know a formula, which is A is equal to omega square into x. By solving for omega square, we will get A divided by x. So we can say that 12 divided by 3 is equal to 4. Now solving for omega, we will get 2. Now we know that the time period can be calculated by this formula. Here omega is 2, so this 2 cancels this 2, and at last we have pi, which is option C. Therefore, option C is the correct answer. Question number 8 says that in the diagram, two wires are aligned side by side. They both are hooked into different circuits in which the current is switched on to allow current to flow in each circuit. Which of the following statement is correct? As you can see that both wires are close enough that they are in the magnetic field which is produced by each other. Therefore, this magnetic field exerts magnetic force, and as the direction of current in both wires is same, they will attract and move closer. Therefore, we can say that C is the correct answer. Question 9 says that two particles A and B of equal masses are suspended from two massless springs of spring constant K1 and K2 respectively. If the maximum velocities during oscillation are equal, the ratio of amplitude of A and B is, let A1 and A2 be the amplitudes, then the maximum velocity will be A into omega. We know that omega is equal to under root k over m. So from this we can say that A1 under root k1 over mass is equal to A2 under root k2 over mass. If the mass is cancelled, then we will have A1 under root k1, which is equal to A2 under root k2. Now we will solve for the ratio, which will be A1 over A2 is equal to under root K2 over K1. Therefore, we can say that C is the correct answer. Question number 10 says that a heater coil is cut into two equal parts and only one part is now used in the heater. The heat generated will be, now we know that the original coil has a resistance of R and its power is P is equal to V square over R. After cutting the coil, the resistance will be R by 2. So the power will be V square over R by 2. So from this, we can say that we will have 2V square over R, which means we have 2P. The power is doubled. Therefore, we can say that A is the correct answer. Now we know that the terminal velocity is reached when the drag force equals to the gravitational force on the object. So the drag force is given by the Stokes law, which is F drag is equal to 6 pi eta RV. Here eta is the viscosity and R is the radius. And we also know that the gravitational force for a fluid or liquid is constant. So the key factor that will change with the temperature is the viscosity. And this viscosity is inversely proportional to the terminal velocity. So we can see that when the temperature increases, the viscosity decreases and the terminal velocity increases, which is option B. So as the temperature of the fluid increases, its viscosity decreases, which allows the spherical body to move faster because the drag force balances the gravitational force. This results in a higher terminal velocity. Question 12 says that the width of depletion region of a junction is reduced under forward bias because depletion region becomes narrow as all the majority carriers moves towards it. And this occurs because applied forward bias voltage reduces the potential barrier, which results in reducing the size of the depletion region. Therefore, we can say that C is the correct answer. Question 13 says that in a Young's double slit experiment, if the monochromatic source is replaced by a source of white light. Now here I have a slit. If monochromatic source is replaced by a source of white light, then when the white light drops on this slit, the central fringe will be white, while if we move away from the central fringe, we will see different colors. So we can say that B is the correct answer. Question 14 says that in a two input logic gate, both inputs are at 0 and the output is 1. The gate would be, we know that a NAND gate is the opposite of AND gate. So it gives 0 only when the inputs are 1 and 1. And if we talk about the NOR gate, we know that the NOR gate is the opposite of OR gate. So we can say that it gives 0 to every other input and 1 to the inputs when they are 0, 0. And then we have exclusive NOR gate, which gives 1 to 1 and 0 and 0 as well. So according to the question, or both inputs are 0. So all of these gates will give output as 1. Therefore, we can say that D is the correct answer. Question 15 says that a uniform elastic field and a uniform magnetic field are acting along the same direction in a certain region. If an electron is projected along the direction of the fields with a certain velocity, then now here I have this region. It has elastic field and uniform magnetic field. When an electron comes in this region, it consists of electric field. And as the electric field enters these fields, it will decelerate and it will oppose the motion of the electron. Therefore, we can say that its velocity will decrease. Question 16 says that a parallel plate capacitor is made by stocking in equally spaced plated connected alternatively. If the capacitance between any two adjacent plates is C, then the resultant capacitance is Now here I have 4 plates, so we can say that n is equal to 4. And now the capacitance between them is C1, C2 and C3 and so on if there are more plates. Now we can say that the total capacitance will be C1 plus C2 plus C3. Now generally we can write it as the total capacitance will be n minus 1 into C. Therefore option A is the correct answer. Question number 17 says that 4 molecules have speed of 2 km per second, 3 km per second, 4 km per second and 5 km per second. The root mean square speed of these molecules in km per second is, we know that we can calculate root mean square values by this formula, which is v1 square plus v2 square plus v3 square plus v4 square divided by 4. We have 4 plus 9 plus 16 and plus 25 divided by 4. By solving it, we will get under root 54 by 4. By simplifying it, we will get under root 54 by 2, which is option C. Therefore, option C is the correct answer. Question 18 says that a boy playing on the roof of a 10-meter high building throws a ball with a speed of 10 meters per second at an angle of 30 with the horizontal. How far from the throwing point will the ball be at the height of 10 meters from the ground? Now we know that the boy is at 10 meters of height. He throws the ball with an angle of 30 degrees from the horizontal. Now we have to calculate the range of the ball when the ball was 10 meters high. So here we have the velocity, which is 10 meters per second. We have the height, which is 10 meters, and we have the angle theta, which is 30. So we will use the formula of the range, which is r is equal to v square sine 2 theta over g. By putting values and solving it, we will get 5 under root 3, which is equal to 8.66 meters. Therefore, option D is the correct answer. Question 19 says that a rope stretched between two fixed points can support transverse standing waves. What is the ratio of the sixth harmonic frequency to the third harmonic frequency? Now we know that the formula to calculate the harmonic frequency is this. Here n is the harmonic number, v is the wave speed and l is the length. So for n is equal to 6 and n is equal to 3, we will have the harmonic frequency as f6 is equal to 6v over 2l, and for n equal to 3, we will have 3v divided by 2l. To calculate the ratio, we will just divide these frequencies and we will have 3v over L, which we get by simplifying it, which is 3v over L divided by 3v over 2L. So by solving it, we will get 3v divided by L into 2L divided by 3v. So we will have our answer as 2. Therefore, B is the correct answer. Question 20 says that what is the particle emitted during the reaction? Now to calculate this particle, we will name it as particle X. Now if we talk about the atomic number, on this side of the equation we have atomic number as 6, while on this side we have 6. So our new particle has atomic number 0. Talking about the mass number on this side of the equation is 13, while on this side we have only 12. So we can say that our new particle has one mass number. So we know that the particle with atomic number 0 and mass number 1 is a neutron. Therefore, option B is the correct answer. Question 21 says that a wire of length 50 cm and cross-sectional area of 1 mm square is made of a material of Young's modulus 2 into 10 raised to the power of 10 Newton per meter square. How much work is done in stretching the wire through 1 mm? We know that the length of the wire is 50 cm and the cross-sectional area is 1 millimeter square, and the extension in the wire will be 1 millimeter. So we know that the work done applied in stretching the wire is stored as potential energy. So we can say that W is equal to del U, which is equal to 1 over 2 into F into del L. To calculate the F, we will use a Young modulus, which is given by this formula. By simplifying it for F, we will get AY del L divided by L. By putting this value of F here, our equation will become 1 over 2 into AY over L into del L whole square. Now we will put values in this equation, which are 1 over 2 into 10 raised to the power of minus 6 into 2 into 10 raised to the power of 10 divided by 50 into 10 raised to the power of minus 2 into 10 raised to the power of minus 3 whole square. By solving this, we will get 2 into 10 raised to the power of minus 2, which is option D. Question 22 says that the resistance of hot tungsten filament is about 10 times the cold resistance. What will be the resistance of 100 watt and 200 volt lamp when not in use? So according to the question, the resistance is equal to 10 times the cold resistance. So we can say that cold resistance is equal to the hot resistance divided by 10. We know that the formula of resistance is equal to V square over P. So by putting values, we will get 200 whole square divided by 100, which is equal to 400 ohms. Now, if we put this into this formula, we will get 400 divided by 10, which is 40 ohm. So we can say that the cold resistance is 40 ohm, which is option A. Question 23 says that if R is the range of the projectile, then its kinetic energy be maximum after covering a horizontal distance. Now we know that the formula of kinetic energy is equal to 1 over 2 mv square. So the projectile has two velocity components, the horizontal component and the vertical component. The vertical component of the velocity of a projectile is 0 as its maximum height. So vertically, the projectile will have no kinetic energy. And the horizontal velocity of a projectile is always constant. So basically, at its maximum height, the kinetic energy of a projectile is equal to the amount of kinetic energy calculated with the horizontal velocity, because the projectile still moves horizontally if it is at rest vertically. So the kinetic energy is maximum at range R. Therefore, option D is the correct answer. Question 24 says that an alpha particle moves through potential difference of 1 volt. It may gain kinetic energy equal to. We know that an alpha particle consists of 2 protons and 2 neutrons. So it has a plus 2 charge on it. And we know that kinetic energy of a charge can be measured by this formula. So here Q is 2 while V is 1. Therefore, we can say that its kinetic energy is 2 electron volt, which is option B. Question 25 says that when charges become twice and their separation also becomes twice, then Coulomb's force between them. Now we know that the Coulomb's force is F is equal to Q1 Q2 divided by R square. Now if Q1 is equal to 2Q1 and Q2 is equal to 2Q2 and radius is also equal to 2R, then the Coulomb's force will be 2Q1 into 2Q2 divided by 2R whole square, which will be 4Q1 Q2 divided by 4R square. As this 4 cancels this 4, we will get Q1 Q2 divided by R square, which is equal to the previous force. Therefore, we can say that the Coulomb's force remains same, which is option A. Question 26 says that the work function of a substance is 4 electron volt. The longest wavelength of light that can cause photoelectron emission from the substance is approximately. Now we need to see the relationship between the work function and energy of the photon. The energy of the photon must be equal to or greater to the work function for photoemission to occur. So we can say that phi is equal to hc over lambda. Here h is the Planck's constant, c is the speed of light, and lambda is the wavelength. Now we have the work function, which is 4.0 electron volt. To convert it into joule, we will simply multiply it by 1.602 into 10 raised to power of minus 19, which will give us 6.408 into 10 raised to power of minus 19. Now putting this into this formula and solving it for lambda, we will get this formula, and the answer will be 310 nanometers, which is option C. Question 27 says that if two mirrors are kept at 60 degrees to each other, then the number of images formed by them is. Now we know that the formula to calculate the number of images is 360 divided by theta minus n. Here theta is 60 degrees. So by putting values, we will get 360 divided by 60 minus 1, which is equal to 6 minus 1, and the answer is 5, which is option A. Therefore, option A is the correct answer. Question 28 says that what is the equivalent resistance between A and B in the figure given below? To calculate the equivalent resistance, we know that the current goes from this side to this side and then here. If we name all of these resistance, this is R1, R2, R3, R4 and R5. We can see that R1 and R2 are connected in series, so the resistance between R1 and 2 will be 5 plus 5, which is equal to 10. So we can just erase it here and just make our new path, which will be, and here I have a resistor whose resistance is 10. Now we can see that this resistor R12 is connected in parallel with R3, so these are equivalent resistance. So when the values are same, the resistance is R by 2, which is equal to 10 by 2, which is equal to 5. So now this complete becomes a single resistance whose resistance is 5 ohm. Now if we have a resistor with 5 ohm, we can see that the current passes through this resistor and then goes into this resistor here. Now we can say that these are connected in series. We can say that this R1, 2, 3 and when connected to 4 gives us 5 plus 5, which is equal to 10 ohm. Now we know that this part of the circuit gives us the resistance of 10 ohm. So we can say that this part is connected in parallel with this part here, and these parallel resistances are equal, so the resistance will be halved, which is R is equal to R by 2, which is equal to 10 over 2, and the answer will be 5 ohm. Therefore, the resistance between point A and B is 5 ohm, which is option A. Question 29 says that what is the resistance in the parallel circuit above points B and C? Now here I have point B and point C. The equivalent resistance will be between them. Now we know that in a parallel circuit the equivalent resistance is equal to 1 over Req is equal to 1 over R1 plus 1 over R2. By putting values, we will get 1 over 3 plus 1 over 6, which will give us 1 plus 2 divided by 6, and we will get 1 over 2 as our inverse of equivalent resistance. So equivalent resistance will be 2 ohms, which is option A. Question 30 says that two inputs of NAND gate are sorted. The gate is equivalent to. Now here we know that a NAND gate consists of an AND gate and then a NOT gate. Now here in our case we have a single input which is A. The input will be 0 or 1. Now when it passes through the NAND gate, the output will be Y, which will be 0 and 1. And when it passes through the NOT gate, it will be Y complement, which is 1 and 0. Now here you can see that the complete output is the inverse of the inputs. Therefore, we can say that our NAND gate will act as a NOT gate. That's all for this video. Thank you.